Hello everyone, welcome to my YouTube channel School of Chemistry. So today's topic is Hess law of thermodynamics. Now you have studied about this law. Okay. Now what does this law states? It states that whether a process takes place in a single step or in multiple steps, the total enthalpy change the total enthalpy change within the process will be same. That is, let us take a process which is getting converted from A to D. Okay, and the total enthalpy change for this process is delta H. And suppose the same reactant can be converted into the D product by first converting it into product B, then we can convert into product C, and then C can be converted into D. But for these three steps, the enthalpy change will be delta H1, delta H2, and delta H3. So we can write that. So delta H must be equal to delta H1 plus delta H2 plus delta H3. Let us take an example of oxidation of carbon with air with oxygen. So when carbon get oxidized in CO2 completely, it leads to the formation of CO2 gas, and enthalpy change for the process is minus 393.5 kilojoule per mole. Okay, this much amount of energy is liberated. But if we carry on the process into the two different steps, that is carbon plus half O2 and convert it into carbon monoxide, the enthalpy change, that is delta H1 for this process would be minus 283 kilojoule per mole, and further oxidation of CO with further half O2 to CO2, enthalpy change for the second process delta H2 would be minus 110.5 kilojoule per mole, stating that the enthalpy change for the complete process, that is when we add the enthalpy of delta H and delta H2, it will comes out to be equal to minus 393.5 kilojoule per mole. Okay, now let us study one of the application of this Hess law, that this Hess law can be used in order to calculate the enthalpy of formation of any compound. Let us take an example from the NCERT, that the combustion of 1 mole of benzene takes place at 298 Kelvin and 180 M. After combustion, CO2 and H2 are produced and 3267.0 kilojoule of heat is liberated. Calculate the standard enthalpy of formation of benzene. Now the standard enthalpy of formation of CO2 and water are also given, that is minus 393.5 kilojoule per mole and minus 285.83 kilojoule per mole. Now how to start with this reaction, or how to start with this question? In order to start with this question, we have to first write down the initial reactions which are given to us. So the first reaction which is given to us is the combustion of 1 mole of benzene. 1 mole of benzene will be taking 1 mole C6H6, Okay, we are going to burn it in air, and when we are going to burn it in air, we will be getting CO2 plus H2O, and the enthalpy change for the process is given minus 3267 kilojoule of heat is liberated. Liberated means there should be a negative sign before the enthalpy change. Now, one thing we should keep in mind that while writing this equation must be balanced. As we can see in the reactant side, we are having 6 carbon atoms, so we can put 6 in front of CO2 and 3 in front of H2O. So carbon and hydrogen are balanced. Now it's turn to balance the oxygen atom. So 6 to the 12, 12 plus 3, 15, 15 oxygen atom are there. So we can write 15 by 2 over here so that the equation can be balanced. As we have only 1 mole of benzene, we cannot take this O2 as 15 O2 molecule and 2 molecule of C6H5 because we have only, so it doesn't matter if it comes into the fraction. Take need not to worry about it. Second, we are also given with the enthalpy of formation of CO2 and water that we can write as carbon in solid state plus O2 gas combines to form CO2 gas, and the enthalpy of formation for this process is given to us minus 393.5 kilojoule per mole. One more enthalpy is given, that is enthalpy of formation of water, that H2 plus half O2 gives us H2O, and the enthalpy of formation of water is minus 285.83 kilojoule per mole. Now this is the data which is given to us. Now how to proceed about it, how to solve this question. So in order to proceed for this question, first we need to write down a hypothetical equation, that what we need to calculate. We need to calculate the standard enthalpy of formation of benzene. Okay, now how benzene is formed? Benzene is formed from two elements, carbon and hydrogen. Let us take this carbon. How many carbon? 6 carbon. Okay, 6 carbon plus how many oxygen do we require? Sorry, hydrogen do we require? 3H2 in the gaseous state in order to form this C6H6. This is our hypothetical equation, and enthalpy change for this reaction need to be calculated. Fine. So in this hypothetical equation, we will be using 6 carbon atom. So 6 carbon atom we can get from this equation, which is given to us enthalpy of formation of CO2. That is, so we need to multiply this whole equation by 6. We can write 6 carbon plus 6 O2 gives us 6 CO2 in the gaseous state, and the enthalpy change for this process will also become 6 times, that 6 into minus 393.5, okay, and that will be equal to, and that will be equal to 2361 kilojoule of heat. Okay, so let me change it, draw. Okay, it will comes out to be 2361 kilojoule, and that will be negative, minus 2361 kilojoule. This much amount of heat will be obtained when we you can say oxidize 6 carbon atom. Okay, now according to the equation we will be requiring 3H2, so we need to multiply this equation, that is formation of water, by 3. So 3H2 in the gaseous state combines with 3 by 2 O2 again in the gaseous state gives you 3H2O, again gaseous. So the enthalpy change for that process comes out to be 3 multiplied with minus 285.83. So when we multiply 3 with 285.83, 285.83, it comes out to be minus 857 38.49. Okay, this is the enthalpy change when we have oxidized 3 hydrogen atom in oxygen to form 3 water molecules. This is the enthalpy change which we have obtained. That is 857.49. Okay, now we need to add these two equations. Okay, why we need to add this equation? Because there is a addition between 6 carbon and 3 H2. So when we add these two equations, we will be getting 6C plus 3H2 plus 15 by 2 O2, which gives us 6 CO2 plus 3 H2O. And the enthalpy change, total enthalpy change for this process becomes, that is delta H, that will be equal to minus 2361 minus 857.49. Okay, means they are going to be added up into each other. Okay, and we will be obtaining over here as 3218.49 kilojoule of heat will be liberated, and it will be in the negative. Fine. Okay, now we have obtained over here. And what's the reaction for the combustion of benzene? Reaction for the combustion of benzene, which is given to us, is this. Now reverse this equation. If we reverse this equation, it could be written as 6 CO2 in the gaseous state plus 3 H2O gives us C6H6 plus 15 by 2 O2. If we reverse this equation, the enthalpy change for the process will also be reversed, means the sign of the enthalpy change will be reversed. That is, it's this much 3267 kilojoule of energy was liberated. Now this much amount of heat will be consumed. That is, it becomes 3267 kilojoule per mole. Okay, now add up these last two equations. If we add these two equations, what we can see, that 6 CO2 get cancelled, 3H2O 3H2 get cancelled, 15 by 2 O2 15 by 2 O2 get cancelled, and what we have obtained? We have obtained 6 carbon plus 3H2 in the gaseous state gives us C6H6. Okay, and the total enthalpy change for the process becomes 3267 minus 3218.49. Okay, so enthalpy change for the process would be 0.51, and over here it becomes 6, 15, 8, 4, 7, 16. Okay, it becomes 3267 48.5. Okay, so it will be positive, having a positive value. It won't be negative. It's mentioned wrong in the NCERT. The sign for this enthalpy change is given as, so enthalpy change for the process will be positive 48.51, and that is kilojoule per mole. Fine. So this is the total enthalpy change for the formation of one mole of benzene. This is how we can use the Hess law to calculate the enthalpy of formation of different molecules by using the enthalpy change of the different reactions which are given to us. Hope my videos are helping you in your studies. So please, for more interesting video, like and subscribe to my YouTube channel, School of Chemistry. Thank you.